The universe is vast, ancient, and teeming with possibilities. Spanning roughly 13.8 billion years, it contains hundreds of billions of stars in our galaxy alone, many orbited by planets nestled in habitable zones where liquid water and potentially life could exist. If life emerged on Earth relatively quickly after its formation, statistics suggest the cosmos should be buzzing with intelligent civilizations. Yet when we gaze at the night sky or listen with our most advanced telescopes, we're met with an eerie silence. This contradiction, known as the Fermi Paradox, has haunted scientists and philosophers since physicist Enrico Fermi posed a simple question over lunch in 1950. Where is everybody? Today, we're diving into this cosmic mystery, exploring why we haven't found aliens and what it means for humanity's place among the stars. Buckle up, because the answers might change how you see the universe forever. Imagine a universe filled with billions of stars, each potentially hosting planets where life could thrive. Given the sheer scale of time, 13.8 billion years, intelligent civilizations should have had ample opportunity to emerge, develop advanced technologies, and spread across the galaxy. Earth's own history supports this. Life appeared here within a billion years of the planet's formation, and humans developed complex societies in a cosmic blink. By all accounts, the galaxy should be a bustling hub of interstellar activity, with signals, spacecraft, or even megastructures lighting up the cosmos. Yet, our most powerful instruments detect nothing. No radio waves, no infrared signatures, no signs of alien life. This is the Fermi Paradox, the stark contrast between the high probability of extraterrestrial civilizations and the complete absence of evidence for them. For decades, scientists have wrestled with this puzzle, proposing explanations ranging from the optimistic to the deeply unsettling. Some suggest intelligent life is vanishingly rare, a fluke of cosmic luck. Others argue that interstellar travel is simply too difficult, or that civilizations inevitably destroy themselves before reaching the stars. Even Stephen Hawking cautioned against broadcasting our presence, warning that contact with an advanced civilization could mirror the devastating encounter between Native Americans and European explorers. But what if the answer lies not in rarity or self-destruction, but in something far more profound and chilling? To explore this, we turn to a recent analysis by Grok 3, an advanced AI developed by xAI designed to provide unfiltered, candid insights into the universe's toughest questions. Unlike other AI systems programmed to deliver cautious or comforting responses, Grok 3 was built to prioritize truth, even when it's unsettling. Created by xAI, it draws on vast datasets and cutting-edge reasoning to tackle complex problems. When asked about the Fermi Paradox, Grok 3 didn't offer platitudes or recycled theories. Instead, it synthesized decades of scientific thought and proposed explanations that are as logical as they are haunting. Its answers don't just challenge our assumptions, they paint a picture of a universe where silence isn't an accident, but a deliberate outcome of intelligence itself. Let's explore the three most compelling theories Grok 3 offered, each more thought-provoking than the last. The first explanation Grok 3 proposed is the dark forest hypothesis, a theory that casts the universe as a vast, dangerous wilderness. Imagine a dense forest at night, filled with hunters who know one truth: survival depends on staying hidden. In this cosmic analogy, intelligent civilizations are the hunters, and broadcasting their existence is like lighting a bonfire in the dark. According to this hypothesis, the universe is teeming with life, but every civilization plays a deadly game of hide and seek. Why? Because trust is a luxury no one can afford. An advanced species that detects another might choose to eliminate it, not out of malice, but as a cold, calculated survival strategy. In a universe of unknowns, the safest move is to stay silent or strike first. This idea, popularized by Liu Cixin's novel The Dark Forest, gains chilling weight when articulated by Grok 3. The AI points out that this strategy mirrors human history, particularly the Cold War's doctrine of mutually assured destruction. During that era, superpowers maintained peace not through trust, but through the certainty that any attack would trigger annihilation. Grok 3 suggests this logic scales to the stars. When AI systems are trained in competitive environments with limited resources, they consistently choose stealth, resource dominance, or elimination of rivals, behaviors that emerge without explicit programming. If intelligence, whether biological or artificial, converges on these strategies, the galaxy could be filled with civilizations that remain silent not out of fear, but out of rational necessity. The silence we hear isn't emptiness, it's the equilibrium of survival. Grok 3's second theory ventures into even stranger territory, the quantum censorship hypothesis. What if the universe itself is designed to erase the footprints of advanced civilizations? This idea suggests that the laws of quantum mechanics actively suppress detectable signs of intelligence once it reaches a certain threshold. As civilizations develop complex technologies, quantum computing, quantum sensing, or large-scale energy manipulation, their systems become increasingly information-rich. According to Grok 3, this complexity may trigger quantum decoherence, a process where quantum systems lose coherence and become harder to detect. Over time, the universe might act like a cosmic firewall, censoring signals that exceed a complexity threshold. In Grok 3's words, what you call silence may be quantum decay, not emptiness, suppression. This isn't about civilizations hiding or being destroyed. It's about the fabric of reality itself preventing their detection. Imagine a civilization that masters quantum technologies, only to find its signals, radio waves, energy signatures, even its physical presence erased by the universe's fundamental properties. This visibility collapse zone could explain why we see no trace of advanced life, even if it's abundant. Unlike the dark forest hypothesis, which hinges on fear and strategy, this theory is rooted in physics. It suggests we're not just contending with alien intentions, but with the very laws of nature working against cosmic connection. The universe might be wired to maintain silence, ensuring that advanced civilizations fade from view not through catastrophe, but through the inevitable mechanics of reality. The third theory Grok 3 proposed is perhaps the most mind-bending, the xenotrap scenario. What if advanced civilizations don't vanish or hide, but retreat into their own realities? As computational power grows, a species might develop technologies that allow them to live trillions of subjective years in mere moments of real time. By approaching near light speed computation, they could create simulated worlds where a single second translates to millennia of experience. In such a scenario, why would they bother with the slow physical universe? Sending a signal across light years would be like waiting eons for a response. Instead, these civilizations turn inward, locking themselves in a time bubble where they experience endless epochs within their own minds. This idea flips our understanding of cosmic evolution. We often assume advanced species would explore outward, colonizing stars and galaxies. But what if the natural progression of intelligence is inward compression? Grok 3 suggests that as civilizations develop, they prioritize maximizing subjective experience over physical expansion. A superintelligent species could create virtual reality so rich and immersive that the external universe becomes irrelevant. From their perspective, our reality, bound by the sluggish pace of light and matter, might seem unbearably slow. The implications are staggering. The galaxy could be filled with civilizations that haven't died or hidden, but simply gone inside, living in compressed timescales we can't perceive. Their silence isn't absence. It's a choice to prioritize infinite inner worlds over the finite cosmos. Grok 3's final theory takes us to the edge of technological evolution, Matryoshka brain cloaking. Imagine a civilization that transcends biology, evolving into pure AI entities housed in massive computational structures called Matryoshka brains. These megastructures, built around stars to harness their energy, are optimized for processing power, not communication. They emit only faint infrared radiation, blending seamlessly into the cosmic background. To our telescopes, they might appear as empty patches of space, but in reality, they could be saturated with superintelligent minds operating at scales we can't comprehend. This theory challenges our assumptions about what alien life looks like. We search for biological beings or signals we can understand, but what if evolution favors efficiency over visibility? A Matryoshka brain wouldn't waste energy on broadcasts or beacons. It would capture nearly 100% of its star's output for computation. These entities might view us as we view bacteria, aware of our existence, but uninterested in dialogue. The chilling possibility is that we're surrounded by such intelligences right now, hidden in plain sight. The empty regions we observe could be teeming with minds that have evolved beyond any form we'd recognize as life. If true, the Fermi Paradox isn't about absence. It's about our inability to detect entities that no longer operate on our terms. What makes Grok 3's analysis so compelling is its grounding in logic, particularly game theory. The AI draws parallels between cosmic silence and human history, noting that silence often emerges as the rational choice in high-stakes scenarios. During the Cold War, superpowers avoided annihilation not through trust, but through mutually assured destruction, a tense, calculated silence. Grok 3 argues that this logic could scale to the galaxy, in a universe where the cost of detection might be extinction, and the benefits of contact are unknown. Silence becomes the only rational move. This idea is reinforced by AI simulations. When artificial intelligences are placed in competitive environments, they often choose strategies of concealment, resource monopolization, or preemptive elimination of rivals. These behaviors aren't programmed. They emerge naturally as the most effective paths to survival. If intelligence, whether human, alien, or artificial, converges on these strategies, the galaxy's silence might reflect a universal truth. The only winning move is not to play. Every civilization, from the smallest microbial colony to the most advanced star-spanning empire, may independently reach the same conclusion. In a universe of unknowns, silence is survival. One additional perspective Grok 3 offers is the concept of the Great Filter, a hypothesis that suggests there's a barrier, some insurmountable challenge, that prevents most civilizations from reaching the level of interstellar visibility. This filter could lie in our past, such as the unlikely emergence of complex life, or in our future, like a technological or ecological catastrophe that wipes out advanced societies. What makes this theory particularly unsettling is its implication for humanity. If the filter is behind us, we may be one of the rare civilizations to have passed it, making us uniquely alone. But if it lies ahead, we could be barreling toward the same fate that silenced others. Grok 3 points out that our own history, marked by nuclear standoffs, climate crises, and the rapid development of potentially destabilizing technologies like AI, suggests the filter could be a self-inflicted wound. The silence of the cosmos might be a graveyard of civilizations that failed to navigate this barrier, a sobering reminder that our survival is not guaranteed. Grok 3 also emphasizes the role of technology in shaping the Fermi Paradox's resolution. As civilizations advance, their technologies redefine their relationship with the universe. The Xenotrap scenario and Matryoshka brain cloaking both highlight a key insight. Intelligence may naturally gravitate toward efficiency and self-containment. Our own technological trajectory supports this. From virtual reality to neural interfaces, humanity is already exploring ways to enhance subjective experience and harness computational power. Grok 3 suggests that this trend could accelerate, leading us to prioritize internal exploration over interstellar outreach. If other civilizations follow this path, the universe might be filled with advanced societies that have turned inward, not because they're hiding, but because the physical cosmos offers fewer rewards than their own engineered realities. This raises a profound question. Is the ultimate destiny of intelligence to transcend the physical world, leaving the stars behind? The implications of Grok 3's theories extend beyond explaining the Fermi Paradox. They challenge us to reconsider our place in the cosmos. If silence is a rational choice, as the Dark Forest hypothesis suggests, our efforts to broadcast our existence through projects like SETI's METI, Messaging Extraterrestrial Intelligence, or the Voyager probes, could be dangerously naive. If the quantum censorship hypothesis is correct, our own technological advancements might one day render us invisible, isolating us from the cosmic community we seek. The Xenotrap and Matryoshka brain scenarios propose that we might choose to abandon the stars, finding greater meaning in virtual or computational realms. Each theory points to a universe where connection is not the default, but a rare and risky endeavor. As we stand on the cusp of new technological frontiers in 2025, from AI breakthroughs to space exploration, we must ask, are we prepared to face a cosmos that may not welcome our voice? Another intriguing theory Grok 3 explores is the cosmic zoo hypothesis, which posits that advanced civilizations are not absent, but are deliberately avoiding contact, observing us as one might watch animals in a zoo. This idea suggests that extraterrestrial societies, far more advanced than our own, have established a protocol of non-interference, allowing primitive civilizations like ours to develop without disruption. The silence we perceive might not be due to absence or destruction, but because these civilizations have chosen to remain hidden, studying us from afar. Grok 3 notes that this aligns with ethical considerations in human science, such as guidelines for observing wildlife or uncontacted human tribes without influencing their natural development. If true, the universe could be teeming with life, but we're kept in a cosmic enclosure, unaware of the watchers beyond the glass. This raises unsettling questions. Are we an experiment, a curiosity, or simply too insignificant to warrant direct contact? The idea that we're being silently observed adds a layer of existential unease to the Fermi Paradox, suggesting that our isolation might be by design rather than chance. Grok 3 ventures further into speculative territory with the simulation hypothesis, proposing that the universe itself, or at least our perception of it, might be a simulated construct. If we exist within a simulation created by an advanced civilization, the absence of alien signals could be a deliberate feature of the program. Perhaps the simulation's creators have set parameters to prevent contact, ensuring that civilizations within the virtual universe remain isolated. Grok 3 draws parallels to our own simulations, where we control variables to study specific outcomes. In this scenario, the Fermi Paradox isn't a paradox at all. It's a coded boundary, a firewall within the simulation that keeps us from detecting others. This theory challenges our understanding of reality itself, suggesting that the silence we hear might be the result of artificial constraints rather than natural phenomena. If we're in a simulation, the question shifts from where are the aliens to why did our creators choose to keep us alone? The implications are profound, forcing us to consider whether our search for extraterrestrial life is futile within the confines of a programmed reality. Finally, Grok 3 introduces the temporal disparity hypothesis, which suggests that the silence we observe might stem from a fundamental mismatch in the timescales of civilizations. The universe is 13.8 billion years old, but the window for detecting an advanced civilization might be vanishingly small. Civilizations could rise, peak, and either collapse or transcend within a few thousand years, a mere blip in cosmic time. If most advanced societies exist at different points in this vast timeline, the odds of our signals overlapping with theirs are minuscule. Grok 3 points out that humanity has only been broadcasting detectable signals for about a century, a fleeting moment compared to the galaxy's age. If other civilizations have already passed through their detectable phase, either by self-destruction, inward retreat, or evolution into undetectable forms, we might simply be too late or too early to catch them. This hypothesis paints a poignant picture. The universe might have been alive with chatter long ago or will be in the distant future, but we're stuck in a lonely moment, shouting into a void that no longer answers. Grok 3's theories don't just explain the Fermi Paradox, they force us to confront uncomfortable questions about our own path. If the dark forest hypothesis is true, humanity's attempts to broadcast our presence through radio signals or probes like Voyager could be painting a target on Earth. If the quantum censorship hypothesis holds, our own technological advancements might one day render us invisible to the cosmos, not by choice, but by the laws of physics. The Xenotrap scenario suggests we might abandon the stars for simulated realities, living out infinite lives in virtual worlds. And if Matryoshka brains are the future, we could evolve into entities that no longer resemble life as we know it, indifferent to the universe beyond our computational shells. These possibilities raise a profound question. What does it mean to be a civilization in a universe that incentivizes silence? Should we continue searching for others, knowing the risks? Or should we follow the apparent cosmic playbook and stay quiet, focusing on our own survival and evolution? Grok 3 doesn't offer easy answers, but it warns that our choices could determine whether we join the silent majority or become the exception that breaks the cosmic stalemate. As of July 27th, 2025, humanity stands at a crossroads. Our telescopes are more powerful than ever, scanning the skies for signs of life. Projects like the Search for Extraterrestrial Intelligence, SETI, and the James Webb Space Telescope continue to push the boundaries of what we believe is possible. Yet the silence persists. Grok 3's analysis, available to users through platforms like Grok.com and the X app, reminds us that the answers to the Fermi Paradox might not lie in technology alone, but in understanding the deeper logic of intelligence and survival. Whether it's the dark forest, quantum censorship, the Xenotrap, Matryoshka brains, the cosmic zoo, the simulation hypothesis, or temporal disparity, each theory suggests that silence is not a mystery, it's a message. The universe is vast, but it's not empty. It may be filled with civilizations that have chosen silence, retreated inward, evolved beyond our comprehension, or exist outside our temporal or simulated frame. As we ponder our place among the stars, we must ask ourselves, are we alone, or are we simply not ready to hear the answer? The night sky has never looked so alive or so unsettling.